Hi, this is Thomas from Apex Game Tools. In this video we're going to look at runtime grid creation. So instead of setting up a grid at design time, we're going to set it up at runtime and initialize it there. So in this scene we have no grid component in our game world. Instead we're going to use a script to create one. So to create one, you start by defining the configuration for the grid. This is done through the grid config class, and as you can see, it has the same properties that you would normally see in the inspector for the grid. And you can then specify all the ones you want to set. In this case, we've set all of them. If you just want to use some of the default values and just override the ones that you don't want, you can do that. You can always see the default values on the grid config class here. So once we have the config ready, you can just call the create method on the grid component and pass it a host that will host the grid. This is a game object, and then you can pass it the config that we just created. This will give you a reference to the grid, and then you can call initialize on that grid, and then you pass that two arguments, the first of which is the max amount of milliseconds per frame that the grid is allowed to use while initializing, and the second one is the callback that will be called once the grid has finished initializing. We've just left this at null at this time. We'll get back to this a bit later to see what we can do there. Now there is a separate video on grid initialization, but just to reiterate, grid initialization is not instantaneous, as this would suggest. So the grid has, well, if it has a height map, it will take even longer, but it takes some frames for the grid to initialize, and the larger the grid, the longer it will take. So this is why we have these settings, max milliseconds and a callback to know when it has completed. There is a second option to create the grid, a method that basically combines the two, create and initialize. So it does exactly what these two do, just in one method call. Alright, so to see this in action, we've also created a unit spawner, which just spawns a unit in the center of the scene, and then it moves it to one of the corners. So let's see what happens when we start the scene. And as you can see, we have our unit spawning, and then we have our unit moving straight into a wall. So this is probably not what we expected to see. We would like to have our unit to actually path around the wall to its destination. But the reason it isn't is that the unit is actually spawned before the grid has initialized, so it has no grid to pathfind on. So in that case, it will just move from its starting position and in a direct line to its end position. You probably also noticed this, that the grid was a little bit delayed because the visualizer didn't actually show the grid at the start when the unit spawned. It just took a little bit of time before it actually showed, as you can see there. So let's try to fix this so that we can have our unit actually pathfind around the obstacle. Now there are a few ways to do this, well, two to be exact. The first is to use the callback that we have in our initialize method. In this callback, you can pretty much do whatever you want. You can send a message to indicate that the grid has finished, or you could reference the unit directly and tell it that it has finished, or whatever else you would want to do. Now for now, just to make one, we can just make a super simple one that will just log that we have finished our initialization. There we go. And oops, that's a bit too many. Obviously not super helpful, but it will just show you how the callback works. As you can see, the callback takes, well, it will get the grid component that has been initialized as one of its arguments, well, the only one. So this doesn't actually help out the situation now, because this doesn't change obviously when the unit spawns. So we'll look at another option that we have. As I mentioned, as one of the options that you would have here would be to send a message, but actually that already happens. So we can just simply subscribe to this message, and then we will have an opportunity to, instead of spawning our units at the start, it will then spawn once we get the message that the grid is ready for use. So to do that, we simply do the standard way of handling messages in ABXPath. We have the interface called iHandleMessage, and the message that you wish to handle in this case is called the grid status message. Now, just to be lazy, I've just created this up front. What you need to implement. So let's start by removing this. We don't want to use that anymore. So instead, the standard thing to do, you have to subscribe to the message bus to be able to handle the messages, and you should also unsubscribe and undisable if you're using the standard message bus. Next up, we have our actually handling of the message. So the first thing we check is that the grid that we're getting information about is actually something that we want to respond to. So in this case, we're just going to check that the bounds of the grid that has finished initializing, or whatever it has done, we don't know what it has done yet, but the message sent is by grid with these bounds. So we just check that this is a grid that we're actually interested in. So in this case, we're just going to see if the grid surrounds our spawn point. If it does, we will then react to the message. Now, the message has two possible status codes. The first is the one we're interested in right now, initialization complete. And once it is complete, we will then spawn our unit. The second option is disable complete, and this allows you to, well, react to the grid being disabled. We're not going to do anything in this case. And that's basically it. So now let's, with this new code in place, let's see how that works. So now you can see the unit didn't spawn right away, it just waited a little bit, and then it spawned once the grid was ready. That's it. That's all you have to know to be able to create runtime grids. Hope that makes sense. See you in the next video.